It's said that a worker was cleaning an oil tank with steam when it started raining unexpectedly, so he wrapped up early and left. But the cold rain kept cooling the tank down. Before long, the tank began to shrink on its own. This phenomenon is known as a vacuum implosion. To recreate this legendary event, they started with a small-scale test. The test subject? A 55-gallon drum. First, they added a small amount of water inside. Then, they heated it until it started boiling. When they saw steam escaping, they sealed the lid tightly. Then, they simply waited for the tank to cool on its own. As time passed, the drum didn't collapse dramatically. Instead, it made a few popping sounds, a sign that it was resisting the surrounding air pressure. But when no one was looking, the drum suddenly gave way. It even startled the photographer. In the end, the drum was crushed into a triangle shape. The reason? The sealed environment created a pressure difference. That pressure difference was strong enough to crush solid steel in an instant. With the success of the small-scale test, a larger-scale test was the next step. But before they could scale up, they needed to know, how much pressure does it take to collapse the oil tank? So they repeated the experiment, but this time with a vacuum pressure gauge. This allowed them to monitor the pressure and calculate the cooling time. From this, they gathered 3 key pieces of data. Next, they changed the heating method to see if directly introducing high-temperature steam would produce the same implosion effect.